Hello, my name is John Boone, and I am editor-in-chief of Medical Physics, the journal. This is a presentation involving three parts: a manuscript preparation, submission, and review. And I will be speaking about manuscript preparation. My managing editor, Al Thomas, will be talking about manuscript submission through the portal. And Dr. Stan Benedict will be, who is the editor for therapy of the journal, will be talking about how the review process goes. So I'm giving this lecture today in my role as editor-in-chief, but I've also been a author of many articles submitted and published in medical physics. So a little bit of my perspective here is on the many manuscripts that I have had a direct hand in preparation of. So manuscript preparation, here's the organization of my presentation, and we'll just get started with the topics in scientific novelty, quality of science, and the like. So the topic, of course, medical physics, the journal has a scope, and the best way to get an understanding of that scope is to read some articles in medical physics and see if those articles are consistent with the article that you plan on submitting. Scientific novelty, we are always looking for new ideas and the like, but there's nothing wrong with a manuscript that reinforces the works of others, especially if you have a new database or a new spin on that approach. The quality of the science should be solid, rigorous, and statistically meaningful. More on that later. And it wouldn't harm if it had utility. If the presentation, if your paper described a useful technique that could be used in either clinically or in a research environment or elsewhere. And of course, what are the components of a high quality manuscript? And there's really no holding back on this. Wonderful science, meaningful title, great figures, clear mathematics, interesting results, insightful discussion, concise conclusion, and perfect English. And let's talk about the organization for scientific journals. And this is tried and true. Of course, there's a title page, and then you have an abstract, introduction, methods and materials, results, conclusions, and references. There's no reason why you should deviate from this tried and true outline for scientific papers. It generally will not work if you do so. With respect to our journal, the title page, we also are looking for acknowledgments. Importantly, if your research is funded by the National Institutes of Health in the United States, then it needs to be recorded in the manuscript in the paper when it's published, and you can see how that is shown on the slide. It's also very important, especially more recently, that you disclose conflicts of interest. Conflicts of interest, even minor ones, are important to the reader, so they understand if you had any financial conflicts of interest here. I'll also say that as editor-in-chief, I put in that I am editor-in-chief, but I am in fact blinded to the review of the manuscript on any manuscript that we submit that has my name on it. The abstract for a research article has 500 words and a technical note 300 words, and we use a structured abstract. There's a background, a purpose, methods, results, and conclusions. And again, those are required elements of your abstract. Don't deviate from that, please. I'm a strong believer that figures tell the story and do them well. I think that most people are visual learners. I certainly am, and I try to do the best I can with figures. And just to illustrate this, there's a paper that I wrote some years ago, and there's a picture of the setup that it was really just a drawing and an image and some intermediate, some methods, a figure pertinent to the methods, some intermediate results, and then the final results. This was 4 little figures in a 5-page paper, concise and to the point. here's a more recent collaboration that I've been on, and so we show pictures of the phantom, of the imaging devices that phantom was imaged on, some dose information, some raw data from the phantom images that are assessed, then the output, and you can see in this case we have 10 figures, very busy figures, and this required 13 pages for this paper. So I'm a believer that figures guide the effort. So you have figures not so much in the abstract or introduction, but in the methods, results, discussion, and the like. And once you have those figures, that's a great place to start. And then fill in the words. You can see that I've drawn those words in here as caricatures. And that's a great way to map out the trajectory of your paper as you begin to write. So statistics. Statistics are essential in a scientific manuscript. They should be described in the methods, not only your definition of significance, but also what tests you use. You can see that we describe that down here in the yellow. We put where we use the statistical packages that we use. The stats should also show up in the text as you're going through your methods and results. And in figures, it's often useful to show statistical significance. We use an asterisk here. A single asterisk was significant at the P.05 level, and the double asterisk meant that it was significant at the P.01 level. And then in the end, these are all concisely described in the abstract. Maybe not all, but the key results should be described statistically in the abstract with p-values. So to get into the nitty-gritty of manuscript preparation, and I'd love to see a perfect manuscript and when I'm writing them, and I'd love to see them when people submit them as well to the journal as I go through my input box every morning as editor-in-chief. So just some perfunctory things. Line numbering. The Medical Physics Journal, it helps facilitate the review if each of the numbers are numbered, each of the lines are numbered. And in Word, Microsoft Word, you go into the layout and then you go to line numbers and you can use that icon and you can see it automatically places numbers in the left-hand column for each of your lines. There's a way to do this in LaTeX as well. I'm not going to read this. I don't read or use LaTeX, but I am thankful for my colleague Dave Rogers for providing this. This document file will be available to you so you can read this in detail later if you do use LaTeX. So please don't just draw goofy, trying to use symbols and the like from PowerPoint or whatever. They end up not really looking like real equations, but use a equation editor, and that usually results in a professional quality equation. We are physicists. Equations are the language of physics, and if you're going to be writing papers for the rest of your career, then invest in a reasonable equation editor. I will say that Microsoft Word comes with an equation editor, and it's just a matter of getting used to using it and using it well. As I show here, I actually own MathType is what is embedded into Microsoft Word. So I understand that this changed more recently, and the best way to do this, as I understand it, is to just use the MathType equation editor in Microsoft Word. So I use equation editor and I cut and paste those equations. That freezes them, and I do it in a high resolution manner. So you blow it up on a large screen and snip that, and then I'll show you how I put it into a line of text. So I create a table that has 3 columns on it, and you can see This is first column, the middle column, and the last column. The last column, I put the equation number in it, and the middle column, I put the equation itself. The first column is there to allow you to adjust the left and right location of the equation when it's finally done. So I'm showing you the table with the boundaries shown, which is a feature in Microsoft Word, and here's the math type insert. Then once it's properly inserted, I go ahead and I hide the boundaries, and you can see now it looks like a centered equation with an equation number that's running along in the text. Does it need to be perfectly centered? No, it would be nice if it looked good for the reviewers, but of course, if and when your manuscript is accepted for publication and becomes a paper, our publisher Wiley has a staff that will properly place the equations into the text using your manuscript as guidance, of course. Figures, there's a million ways to get figures wrong, and way number one is to use the default settings in Excel. I'll admit that I use Excel. It's not the most sophisticated graphics package, but it does do figures pretty well. But the default is this gray background, a small font, which is unacceptable when it shrinks down, and it just results in a imperfect figure. So my advice is to go in and edit the Excel file if you're using Excel, make the crossbars black, make the figure elements large enough, and certainly increase the font to something like 16 or 20 for both the axes and along the labels. And that way, when you shrink this down and it gets inserted into a published paper, you can actually read the font. If you don't do that, then the font will be largely illegible. And so this is just a summary of what the last couple slides were, and this is an example of a well done figure from a colleague of mine. So this is too complicated to go through, but this is actually something that you can find on the website of the journal for author guidelines. And I encourage you to go through and read this, but I'm not going to take the time here to go through this. But it expresses my degree of enthusiasm for getting the figures correctly. I will say that I like figures that have sort of annotations on them, professional annotations, but the figure itself, as I mentioned, I'll use Excel or some other plotting program and get the basics down on the figure, cut and paste those out with a white background into a PowerPoint file. PowerPoint is a program that's useful for annotation, and it really does help to use that for annotating a figure. You can see I've inserted the calendar year 2022 here, and I've also overwritten the labels for each of the titles, axes for this, and there's many other annotations that one can get into, and I talk about that on this slide that's available on the website, as I mentioned. So I am a believer in white backgrounds that make it easy to snip and then cut and paste onto another white background. So references should be professional and should be in the style that's required for medical physics. And if you use a commercial a program like EndNote, which is commonly used, we use the same formatting as JAMA. And so you can go select that, you create your file, and then you use the tools in EndNote. And if you use the JAMA formatting, it will come out in the way that is appropriate for the medical physics journal. English grammar and other sets of eyes. I read manuscripts that I am author of many times, sometimes 45 times as I continue to add text. for my students, I'm a full professor. I have a lab with students in it, and I'm helping them write sometimes their first and second manuscripts. And sometimes they like me to use track changes in Word, but that lets them get off just by accepting all changes, and they don't read what my comments are. I don't write very well, but I hope they can read this. And so this is an example of what I call a red pen, or in this case, it's blue pen. And I go through and I print it out and I write this, and then I scan it and I send it to them, and I let them read what I've said, and they can make the changes. And it's my hope that as students learning to write, they'll look what was said, and they'll look what a senior author, myself, is suggesting, and learn from that experience that I've had. And that's, I consider, a role of a professor, is to teach your students not only how to do good science, but also how to write good science. And that's key to a successful career in whatever you become, a clinical physicist or a research scientist or a government employee. So conclusions, of course, they should be supported by the data. And so if I make a conclusion, I should be able to find the results in the results section that lead to that conclusion. So the conclusions should be supported by the results. Conversely, the results should inform the conclusions. Try to make the results flow cleanly into the conclusion, and that might mean editing the result, not changing it nefariously, but rather making it more straightforward in a manner that it leads to the reader understanding what your conclusions could be and what they are. And then finally, so this is how I prepare manuscripts. But one thing I've learned over the years, and I go back into the early days of computers, archive your manuscript data in figures. Of course, you're going to archive it on the file, and I have a way of doing that. You can see here in my folders on my PC. But sometimes PCs crash, sometimes they're hacked. So I always do offline storage with a memory stick, and put that and store it in a way where you can find it, maybe label the memory stick. Now people are using cloud storage, and that's another safe way, hopefully, of storing your data. When you submit your manuscript, almost always there'll be requests for it to be changed, and so you need to be able to find the original documents, the figure documents, the data, and the text, of course, and you need to work from that original document so you get it right. And so it's very important that you archive these. And in this world where we have a lot of malware and stuff, it's great to store this offline so it's not reachable by nefarious actors on the dark web, and you can always have a good virus-free copy of your manuscript. And with that, I hope I've shared with you some of the tools I've used and rules that I've used in manuscript preparation over my 38-year career as a medical physicist. And I look forward to as editor-in-chief is receiving your well-written manuscripts, and I leave it to Elle now to describe manuscript submission to the portal, and then for Stan Benedict to describe the review process for you all. Thank you very much.